All right, folks, let's do number 32. An object of mass m1 on a frictionless horizontal table is connected to an object of mass m2 through a very light pulley P1 and a light fixed pulley P2 as shown in the figure. If A and 1 are the accelerations of A and 1 and 2 respectively, what is the relation between these accelerations? And the tensions and the strings and the acceleration of A1 and A2 in terms of G and the masses. Anyways, folks, I encourage you guys to pause this video to give this problem a shot. This is going to be a very hard problem to visualize. So, let's answer for what part A is. But before we do that, let's visualize the problem. All right, so let's look at this image. And this image is, I'll be right. All right, so let's see. So as this object moves down, this object, this whole thing, I'm going to pretend that this is connected here in the center, but this right here is going to move, this length right here is going to move sideways in this direction. So as the pulley moves, the strings will have to compensate for the movement. So the strings will move double the amount when this stretches in this direction. That's the key insight to this problem. This is I hope you guys are taking your time on this because this is really hard to visualize. But just understand that this acceleration moves exactly the same as this acceleration. So the A1 and A2 are the same. However, that doesn't mean that the tension that's pulling on T1 is the same. In fact, you can read it as a tension value, or you could treat it as the whole tension if you want, but we're going to do the forces diagram pretty soon. In fact, let's do that right now. Let's draw the forces of the object 2. I'm just going to put it right here. So the forces on the object 2 is going to be the force of gravity, which is m2g, minus the tension, which I'm going to call T2. The string of the pulley here, and the pulley here is just, I'm just going to call this T2 and T2 there for that, just to get that out of the way. We don't need to go that far. But for this one right here, for the pulley here, at this point, we're going to have the tension T2. That just stretches the pulley in this direction. However, the strings that's attached to it, we're going to treat this as T1 for both of these guys. And now the object for the mass 1 is going to be T1. So these are all the forces diagrams that you need in order to get this problem. But one thing to recognize is that the acceleration of the object 2 would have to, or the acceleration for the object 1 would have to be double the amount of the acceleration for the object 2, because as this moves this length right here, in order for the length to compensate here, this would have to stretch out from the pulley. So you're actually moving double the length for this, and because you're moving double the length, you're moving double the velocity and double the acceleration. So in other words, whatever length that A2 stretches out, A1 would have to be double the amount of A2. And in fact, that's really what part A is. So I know this problem is a bit hard to visualize, and I am a bit high on the edibles, but that's all right. So A1 is going to be 2 times A2. That's the answer for part A, and that's a very important distinction to make, folks. Notice that we haven't really done the math yet, but this is more important. All right, now let's find B, the tensions of the string and the accelerations. All right, now I already did the forces diagrams here. So I'm going to call this direction positive. So this direction positive, we're not going to worry about this direction being stretched out, though you could think of it as a tension. But I am going to think of this as T1 being the acceleration m of the object 1 of A1. And T2, I'm going to call down positive. So M2G minus T2, and T2 here is 2 times T1 equals M2 A2. There's the forces diagrams. So T1s and T2s are related. So you can really solve this however you want. So in fact, those are your equations. All right, so let's solve for the tensions. So I'm going to do this separately on these two equations. So we're going to find T1 and T2. All right, so I'm going to multiply by 2 on the other equation. So 2m2g minus 2t2 equals m2 a2. In fact, we're going to do that so we can replace that. T1 equals m1a1. So that means that 2m2g minus 2 times, and we're going to replace that with half of T1. Oh, 2 times T1, I meant to say. There we go, beautiful. Equals M2 A1. From there, we're going to rewrite this to M2G minus 4 T1, or in this case, M1 A1 equals M2 A2. I mean, M2 A1. So therefore, the acceleration of the object 1 is going to equal 2m2g divided by a1 being factored plus the 4, so you'll be left with 4m1 plus m2. And yay, we're done. So the object for the acceleration 2 would be half of that, so a2 would be m2g, even though we were supposed to solve for this tension and I already lost track of what I was doing, plus m2. These equations should. All right, so there's the equation. All right, so let's get the tensions. So T1 here, once you solve it, M1A1, I'm just going to replace this with that equation, A1, so that's 2M1 M2G over the 4M1 plus M2, and T2 would be double that length, so that would be 4M1 M2G over 4M1 plus M2. There's the tensions. And part C is the accelerations. There's the acceleration, 2m2g over 4m1 plus m2. A2 equals m2g, if I did the math correctly, which I think I did. I'm going to have to check this. And usually the way I check it is I usually don't put I don't need to check it on the answers in the back of the book, but usually what I like to do is I like to plug the variables in and make sure I have the math correct. And if the math is correct, then my setup, then if something doesn't match in the answer in the back, then that means that my setup is wrong. But I don't think my setup is wrong. I think this is actually correct. So yeah, so this would be 2 times T1. T1 is there. Mg minus T2 is definitely that. And you work out the math, and then you can get those other equations, and then you can answer all these questions if you guys want. You don't have to. Anyways, I hope you guys enjoy. I hope you guys are learning something out of these. All right, goodbye.